A raindrop of radius 2 mm falls from a height of 500 meters above the ground. It falls with decreasing acceleration due to viscous resistance of air until at half its original height. It attains maximum or terminal speed and moves with uniform speed thereafter. What is the work done by the gravitational force on the drop in the first and second half of the journey? What is the work done by the resistive force in the entire journey if its speed on reaching the ground is 10 meters per second? Take G as 9.8 meters per second square and the density of water is 10 to the power of 3 kg per meter cube. Now I want you guys to pause, read the question and then move on to the next answer. Now what we have the radius to be 2 millimeter, right? So we have 2 into 10 to the power of minus 3 meter. Now density was given to be 10 to the power of 3 kg per meter cube. Now why we need the density? Because from density we can get to know what is the mass. Because density is given by what? Mass by volume. So mass is equal to volume into density, right? Now this is a spherical drop. So 4 by 3 pi r cube into rho will give you the mass, rho being the density. So substitute, we have 4 by 3 into pi into 2 into 10 to the power of minus 3 whole cube into 10 to the power of 3. So we get 3.35 into 10 to the power of minus 5 kg. Now this is the mass of the water drop. Now see what we have work done by the gravitational force, correct? So the work done by that will be equal to gravitational potential energy, right? Now for how much the distance are we moving? Now if you look at the question, the total distance is 500, but for half the distance it's moving, right? So meaning the height will be 250 meters. So we have W is equal to mgh, which is 3.35 into 10 to the power of minus 5 into 9.8 into 250, which gives us 0.082 joule. Okay, now this becomes the work done, correct? Okay, now from conservation of energy, so what we have, energy can neither be created nor be destroyed, correct? Now in this case also, see, first thing is the gravitational potential energy. Okay, so that is the initial energy. The final energy is nothing but the kinetic energy with its moving plus the resistive energy, correct? Because of the viscosity of the air, there will be a little bit of resistance. So we have the gravitational potential energy is equal to gain in kinetic energy plus work done against the resistive force, right? So we have mgh is equal to half mv square plus W resistive. Now one important thing what you guys have to notice is here H is capital H, which is the 500 meters, not the 250 meter, because we are talking about the initial energy. So the water drop was 500 meters above the ground, right? So this is the height what you have to take. So we have W resistive is equal to mgh minus half mv square. Now you know all the values, substitute. So we have mgh, so 3.35 into 10 to the power of minus 5 into 9.8 into 500 minus half into 3.35 into 10 to the power of minus 5 into 10 square, because it's falling at a speed of 10 meters per second, right? So if you solve this, you will get the answer as 0.162 joule. Now since the work done by the gravitational potential energy, and this is basically against the gravitational force, right? Because the resistive force is against the gravitational force. So you have to write the answer as minus 0.162 joule. Okay, the negative sign is because you're going against the gravity. Okay, so just go through the video again so that you understand how the problem has to be done.